Voila! Good day, viewers. I think each and everyone is good, right? Okay. I think as of now, you are coping with my lessons, right? And you are very happy me bringing this channel, right? Okay. So let's proceed. In our previous lessons, we learned about conversion between what? Non-decimal numerals, right? So we did conversion between non-decimal numerals or non-decimal numbers. And what we did over there was that you'll be given what? Other base, and you convert it to what? Other base. Let's imagine we were given our base 2 and we were asked to convert it to what? Base 8. So, and then we said, well, before you can do that, first of all, you do what? You convert from that base to base 10 before converting from base 10 to what? The required base. Are we getting that? That is what we did. Okay, so in today's lesson, we are going to be looking at equations involving number bases. You see, we have so many types of equations, right? We have linear equations, we have quadratic equations, we have simultaneous equations, we even have equations involving what? Indices, right? And I think you know we call them what? Exponential equations. Are we getting that? We also have what? Equations involving logarithms. And that one too is what? Logarithmic what? Equations. And in today's lesson, this one too, we are having what? Number bases, and we have equations containing what? Number bases. So when equations are given, of which we have number bases inside, how do we tackle that? And that is what we are coming to do today. Okay, so when given equations involving number bases to solve, change the bases in both sides of the equations to what? Base 10. Are we getting that? So all that we are going to do here is we are going to change the base in both sides of the equations to what? Base 10. So if it is already in base 10, voila, we are done. We are not going to do anything to it. We only change the side that is not in base 10 to base 10. Then it will send us to what? Either linear or quadratic what? Equation. Then we solve. Please, are we getting that? Let's use an example to explain. Find the value of x. So given this, we know this is what? An equation. And in this equation, we have other base and also what? Base 10. So we have to find the base of this particular what? Numeral. Are we getting that? That is what we have to find. So the first thing we are going to do is to change each side or change each base to what? Base 10. Are we getting that? But when we check the left hand side, this one is not in base 10, but this one is already in base 10. So there's nothing that we are going to do to this one. We are only going to change this one to base what? 10. Please, are we getting that? Then we continue. Okay, so given something like this, let's proceed. I have to first of all write my question, which is what? 25 base x, which is equal to 17 base 10. So that is the question. Now what do we do? I said we're only going to change this side to what? Base 10, but this one is already in base 10, so there is nothing we are going to do to this one. So what do we do? In changing, I think you know we have the group by 8 what? Place or place value. Are we getting that? And here this corresponds to what? The place. So we have the 2 times what? X. Then plus the 2 times, plus 5 times what? X. Which is equal to R17, because that one is already base 10. To give it a 0 and 1. This shows the place and the place. We are aware of this already. Because we said, given what? 2, 3, base 4. To convert to this, then what do? We take the group, we multiply by what? The place. And the place here is 0, here is what? 1. Please, are we getting that? That is what we did previously. So here is 4. So that is the 4 repeating. We use what? The base in creating the place. So here to this is the base. That's what we are using in creating what? The place. Please, are we getting that? Okay. Okay. So now we proceed. And solving this one will give me 2x then plus I have 5, which is equal to minus 17. The 17. Then to proceed, this one will get me, and I think we know this one is linear equation. So since we are having linear now, I think we can continue, right? Okay. So what do? I have my 2x. That is what? Sending those with x to one side and those without x to the other side. So which is equal to 17, then minus 5. We know why it's minus. Okay. Oh, that is, this one is positive. When it crosses the equal sign, it becomes what? Negative. That is the simple idea that we know, right? So this 5 crosses the equal sign. So that is why we are having minus 5. Are we getting that? Okay. So then we have 2x, which is equal to 12. Then we are going to divide both sides by 2 because we want x. Okay. So I'll have x to be equal to the 12 divided by 2. And you could have also written what? 2x over 2, which is equal to 12 divided by 2. And the same thing, I use this one to cancel down. That is why I'm having this one to be equal to as that. Are we getting that? And it's the same thing. So I can say therefore my x is equal to 6. My x is equal to 6. And what does it mean? We are saying that 2, 5 base, what number when we convert to base 10 we'll get that 17? Are we getting that? Or 2, 5 base, what number is equal to what? 17 base 10. Are we getting that? And we said what the base number is 6. So you can prove that to see what we convert this one to base 10, we get this. Are we getting that? So meaning since x is now what 6, I can say what 2, 5 base 6. And we are saying it's equal to 17 base 10. Let's see if it is correct. So to convert this one, we have 2 times the 6, then plus, then the 5 times the 6. Here 0, 1. So this one will get at 4 plus, this one goes 1, so plus 5, and this one will get at 17, and it is the same. So we are saying what value of x when we put here make a statement true, and we are saying that when what x is 6, and it makes sense. Are we getting that? So that is that. So what I said is that whenever you are given equations involving number base, because this one the unknown is what a base. That is why we are saying equation involving number base. So what do? Or even we are having what bases in the equations. So if it's an equation involving number base, what do? We change both sides of the equations to what base 10. All other base we change it to what base 10. Then we solve it either linearly or quadratically. Please, are we getting that? That's all that we did here. So we were able to change this one because this one is in the other base and this one is in base 10 already. So we didn't do anything towards this one because it is already in base 10. And we said that whenever we have what something in base 10 or a number in base 10, you can choose to bring what the subscript 10 or you can choose to ignore that. Are we getting that? So that is that. Okay, let's take the next example. Let's take the next example. That is what? Example number 2. Example number 2. So that one too says, example number 2 says, if 42 base n is equal to, let's say 22 base 10, we have to find the value of n. So solution. So what do? We write a question that is 42 base n, which is equal to 22 base 10. And this implies that converting this one to base 10, I'll have 4 times n plus 2 times n, which is equal to R22. This implies that here 0, 1. I'll have 4n equate 4n plus 2. Sorry. 4n plus 2, because this one will go to 1, which is equal to 22. This implies that 4n is equal to 22 minus 2. Then this implies that I have 4n is equal to 20. Then dividing both sides by 4 will get you n to be equal to 20 on 4. Therefore, Rn is equal to 5. So, what does this one to say? It also says that for 2 base, what number will get you 22 base 10? That is all that we are saying. So we are saying what? 4 2 base 5 will get us 22 base 10. Meaning what? 4 2 base 5, when we convert to base 10 will get us 22. Let's see that. So that one will be 4 2 base 5. Let's see. So I'll have the 4 times the 5 plus the 2 times the 5. 0, 1. So this one gets me 20 plus this one gets me what? 2. So it's 4 2 base 5. That one will convert to base 10 will get 22. So meaning n is what? 5. Are we getting that? Okay. Let's see. Or let's look at example number 3. Example number 3. So example number 3. If 102 base x is equal to 51, find the base number x. Solution. Okay. So let's proceed. So having this one, what do we do? This one is not in base 10, it's another base, but this one is in base 10. So we leave this one like that and we convert this one. So I'll have 102 base x, which is equal to 51. So I will have 1 times my x plus 0 times my x plus 2 times my x, which is equal to 51. 0, 1, and 2. Okay, let's proceed. So this one will get us 1 times x squared is x squared plus 0 plus 2 is equal to 51. And this one is what? Quadratic equation. Right? But since here we are having the term of x squared, but we don't have the term of what? The x. We can use another way, so we will not bother ourselves using the method of quadratics. Are we getting that? Okay. So this one will now get us x squared, then this one will come here to be 51 minus 2. Then furthering up will get us x squared is equal to 49. So here we want x, but not x squared. But what do we do now? And what do we do? Okay, but I think you said that is correct. That is, you find the square root of both sides. And finding the square root of both sides will get us is equal to square root of 49. Why are we finding the square root of both sides? We are finding the square root of both sides because we want this square to go. So we find the square root. It's only the square root that will make the square go. Please, are we getting that? So that is why we are finding the square root of this side. And the equation, whatever I do towards the left hand side, do the same towards the right hand side. So since we are finding what? The square root of this side to make what? The square root. We do the same to this one. Are we getting that? So it will cancel to make it x to equal to. Then what do we do? We have x, this one will cancel that. Why are we saying that square root of x squared and the square will cancel what? The square root. When we get to indices, you understand it better. We will get to know that Whenever we are having square root, it's the same as what? Exponent half. So this one is x squared, then times what? Half. And this one cancels that, leaving x exponent 1, which is the same as what? X. That is why we are saying this one cancels that one. Are we getting that? When we get there, you understand better. So it has cancelled. And whenever we find the square root of a number like 4, the square root is saying that what number multiplies itself to get what is inside, or what number multiplies itself to get what is inside the square root. Are we getting that? So I can write what number multiplies itself to get 4. So writing down one sentence, we have a symbol in mathematics that represents that. So whenever we see square root of 4 or square root, it means a number multiplying itself to get something. Are we getting that? So having this, a number that will multiply itself to get 4 is what? 2 or negative 2. Because 2 times 2 will get us what? A 4. And also negative 2 times negative 2 will also get us what? The 4. So whenever we find the square root of the number, the answer or the number that multiplies itself to get what? The 4 is what? Positive or the negative of the number. Are we getting that? It's not only 2, but negative 2 also gets us the same thing. So whenever we write square root of a number, it's plus or minus the answer. So the square root of 4 now is what? Positive 2 or negative what? 2. So that is how it is written. Plus or minus 2. That is what? Positive 2 or negative what? 2. And positive 2 is this. Positive 2 or negative 2. Please, are we getting that? So we see what? We would have written x is equal to 2 or negative 2. That is the same as x is equal to plus or minus 2. Are we getting that? So finding the square root of 40 now will get that to plus or minus 7. It's positive or negative 7, that will get us what? 49. Are we getting that? So that is that. And getting that one, we are not done. So we can now say that therefore x is equal to what? 7. We are using positive 7 but not negative because a base can never be what? Negative. Because we said that having, let's say, 2, 3 base 4. This one means what? There is a certain number of units that we grouped into what? 4. Groupings into 4. Then we had 2, 3, that. Are we getting that? So meaning we have 3 units and 2 groups of what? 4. Are we getting that? But if we write 2, 3 base negative 4, the negative 4, what does it mean? Are we grouping into negative 4? It doesn't make meaning. Or it doesn't make sense. Are we getting that? So beginning with the number base, we never had what? A negative as what? A base. Please, are we getting that? So since we are having negative 7 or positive 7 for x, since we are referring to number base, the only possible answer that can be for x is what? Positive 7, but then not the negative of it. So you can write because or since base can never be negative. So you can write that since a base can never be negative. Are we getting that? Or you can choose to leave it that way because x is equal to 7 and you understand. You are supposed to know why we are not taking the negative of that. Please, are we getting that? Okay. Example number 4. And that one says if 2, 3 base x is equal to 102 base 6. Find the base number x. The solution. Let's proceed. So having this, what do we do? This one is not in base 10, meaning this one is in other base, this one is in other base. So we are going to convert each side of the equations or each side of the equation to base 10 because this one is not in base 10. So what do we get? We have this, or let me first of all write the question. So we have 1, 2, 3 is x, which is equal to 102 base 6. So this implies that this one will get to be 1 times x plus 2 times x plus 3 times x, which is equal to, then I can 0, 1, and then 2. I'm done with this. Then this one too will get us 1 times 6 plus 0 times 6, then plus 2 times 6. So this one starts from 0 here, 1, and then 2. So continuing, we will get this one get us x squared plus 2x plus 3, which is equal to 36 plus 0 plus 2 for this one. And this one is getting us. Let's look at something here. This one, unlike this one, the term for the x is not inside. So we say quadratic equation because the degree there is what? 2. Or degree of the variable there is 2. And this one, 2, the degree. When we say degree means what? The highest exponent of the variable. Are we getting that? That is what? The highest exponent of the variable. The variable with the highest exponent. Please, are we getting that? Okay. So that is, yeah, we are having x squared. We are having x exponent 1. And we are having x exponent 0. Are we getting that? That is the constant. So having this one, we are having the degree to be what? 2, so quadratic. But after that one, we are also having what? The term of what? The x inside. So this one is typically what? Quadratic. That one too is a quadratic, but we can use other way to solve it. That's the other way we use. But this one, since the term of the x is also inside, we can't use other way unless we use what? The quadratic way. Are we getting that? To solve this one. So since we are having that, we can write the standard form of what? The quadratic. And that one is ax squared plus bx plus c is equal to 0. That is quadratic equation. Are we getting that? We send everything to the left hand side, then we equate to 0. You can send everything to the right hand side, then equate to 0, or you equate the left to 0. Are we getting that? I mean, you send everything to the right hand side, then you equate the left to what? 0. This is the standard form of quadratic equation. It is in the order of decreasing the exponent. Are we getting that? Okay, so let's now proceed. So we can write this one too in that form by having what? X squared plus 2x, then this one crosses plus 3, then minus this plus that. That's what? Minus 38, which is equal to 0. And this one will get us x squared plus 2x, then minus 35 is equal to 0. Are we getting that? So this is what? Now in the form of a standard form of quadratic equation. So getting this, what do? We normally say that we multiply the coefficient of the x squared by the constant to get negative 35. Then we find two numbers that when we multiply, we get negative 35, or we get a constant. And when we add, we get the coefficient of the x, which is what? Positive 2. So what are that two numbers when we add, we get what? 2. But when we multiply, we get what? Negative. The same two numbers when we multiply, we get negative 35. We don't know that number. And sometimes to get those two numbers, it's not very simple. But we have a trick that we use. By using the calculator, we'll get you the two numbers simple. Are we getting that? That is, you get the two numbers to extend this terms to what? 4. You extend the left side, the terms of the left side to what? 4 terms. Then you factorize. You will come back to the but. First of all, we have to know how to get those two numbers. If we are not able to get those two numbers, we get any other numbers which is not the 2 or which are not the 2. It means whatever we are doing is wrong. So we are going to be using the calculator and getting what? Those two numbers. Are we getting that? But before we come to this example, I have certain quadratic equations that I want us to what? use the calculator and getting their two numbers, then we expand that, then we can use that idea to proceed. Are we getting that? So let's take this one, x squared plus 4x minus 21, which is equal to 0. And this one too is what? Quadratic equation in the standard form, right? So, excuse me. Okay, sorry. So I have what? The A, B, and C. They are constant, meaning they are standing for real numbers. They are numbers. Are we getting that? Okay. It can be any number. Okay. So looking at this one, the coefficient of the x squared here is A, x is B, and the constant is C. So the coefficient of the x squared here is what? 1. That of the x is 4. The sign in front of it affects the coefficient. And here is 21, but the sign is negative, so we see negative 21. Are we getting that? The C is negative 21. So that is what we are going to be doing. We have to know what? The A, the B, and the C. Are we getting that? So we take our calculator, then we click on the mode. Then clicking on the mode, we see number 5, that is having EQN. That is EQN, which is the equation. So you click on number 5, and you're having number 1 to 4, right, on the calculator. So number 1, number 2 are for simultaneous equations. When we get there, you understand. Number 3 looks like the standard form of the quadratic equation. So number 3 is the quadratic equation. Number 4, 2, when we get there, you understand. So there is something that I was supposed to speak about. Whenever we are having the degree to be 2, you see, when we are having linear equations like x minus 3 is equal to 5, the degree is what? 1. That is linear, 1. So meaning what? When we solve this one, we get what? Only one answer because the degree is 1. Whenever the degree is 2 and you stop, you get 2 what? Answers. Like this one. The degree is what? 2. So when we solve, we have 2 what? Answers. And we chose one to be at least. So this one too, since it is quadratic, the degree is 2. Whenever we solve this one, we are going to get what? 2 what? Answers. Please, are we getting that? Okay, so now let's proceed. So checking the number 4, we are having ax cubed. So meaning when we solve what? Something of that sort, we are going to get 3 what? Answers. Are we getting that? Okay. I mean something like, let's say x cubed plus 2x squared minus 3x plus 4 is equal to 0. When we solve something like this, we get 3 possible answers for what? The x. Are we getting that? But we are actually interested in what? Quadratic equation. The one with the degree 2. Are we getting that? Okay. So let's proceed. That is number 3. So you click on the number 3, and now you are having A, B, C. And under the A, you are having a bolded what? Line. Are we getting that? Okay. So what do? We are interested in the coefficients. That is A, B, and C. So when we check this one, the A here is what? 1. So here is 1. So you click on 1. And after clicking on 1, you click on equal to. So when you click on the equal to, you see the bolded line moving towards the B. And under the A, you see the 1 you put. Are we getting that? So you click, the B2 is what? Positive 4. You click on 4, you click on equal to. It has now moved to C, and you are seeing the 4 under the B. Okay, then the C, which is the constant, is what? Negative 21. And you click on negative 21. So our negative is what is inside what? The bracket. Negative. And we have minus. The bar for the minus is longer than that of what? The negative. So negative is what is in the parentheses. So you check to your left hand side on the calculator, right under the fraction sign, you see the negative. That's what I'm talking about. So don't click on minus 21. You click on negative this one. Then you click on your 21. You click on equal to. And you are having the first value for x. So that is x1, right? It's equal to 3. And you click on it again. Then you are having x2 to be equal to what? Negative 7. Are we getting that? So this one is how the calculator is conditioned. We are in number basis, and when somebody sees this, the person is going to say that this one is what? X base 1, X base 2. It's the calculator. to tell you what, we are having two values for the x, the first one and the second one. It doesn't mean anything. So me, what I normally write is what? X is equal to 3 or x is equal to what? -7. And that is what I want you to be writing instead of what? This one. Are we okay? Okay, so now we are having the two values for what? X. And who can tell me the denominator for the answers? Okay, I hope you said what? Here, the denominator here is what? 1. And here too is what? 1, but we don't write it, right? Okay. So they are 1 because the coefficient of the x squared is what? 1. But when the coefficient of the x squared is not 1, and let's say it is 3, the denominators are supposed to be 3, 3, 3. When we get there, you understand. Are we getting that? Okay. So immediately we get the answers, and the denominators are the same as the coefficient of the x squared. I come again. Immediately we get the answers, and the denominators are the same as the coefficient of the x squared, meaning we are done. We do last thing. Are we getting that? So here is over 1 is over 1, put this here. So it's the same. Then after getting that, what do? We change their signs. We change their sign. So changing the sign of this one is positive, and it will get us -3. And changing the sign of this one is what? This one is -7, and it will get us what? +7. Are you with me? Oh, it seems a lot of you are doing their own thing. Please. Yeah, you come back. Hello. Okay. Let's proceed. So immediately you change their signs. Then the two numbers that you get are the numbers we are talking about. Are we getting that? Immediately you change their signs. The two numbers that we get are the numbers we are talking about. So the two numbers, so this one, I multiply this one by this, right? I'm coming. This one, what do I do? I multiply this one. Where is it? I multiply this one by this one, and I get what? -21. So we are looking for the two numbers. Hello, are we here? Okay. We are looking for the two numbers. When we multiply, we get -21. But when we add, we get +4. And we are seeing the this. So -3 times 7 is -21. And this plus this will get us what? The coefficient of the x. That is +4. You see, we've gotten the numbers. So they are the two numbers. Then whenever we see what? This one, the coefficient of this one, we put what? This and that. Are we getting that? So it is going to be something like this. X squared. Then -3x because we had negative. Then this one is positive, so I can say plus 7x. Then the constant there is -21 is equal to 0. Then we've made this one what? 4 terms. Then we group them into 2. From algebraic expression, that's what we will do. We should factorize. Then we factorize this side separately, this side separately. That is the idea. But the trick I'm giving you is to get what? The two numbers. Because that is what sometimes it makes it more difficult. Are we getting that? So now we are having the two numbers. I take another example for you to understand it better. Okay, another one is what? X squared. X squared minus 2x. Is it minus 2x? Yeah. Minus 3 is equal to 7. Are we here? Here too, the coefficient of the x squared is what? 1. So meaning what? The denominators of the answer are also going to be 1, 1, 1, 1 after putting it on the calculator. Are we getting that? Let's see. So putting this one, the same thing. We are still there, right? On the calculator, we are still there. So somebody will say, I'm having -7 on the calculator. Click on the equal sign again, and it will come back to ABC. Are you getting that? Okay, good. So I have what? The coefficient here to be 1. Then this one is what? Now -2. So I put -2. And this one, the constant is -3. I put my -3. After you are done with that, you click on the equal sign. You are having x to be equal to what? 3. Or x to be equal to what? -1. You see, the denominator is 1, the denominator is 1, which is the same as the coefficient. Are we okay? So somebody will say, I'm having x1, x2. I said that one is to tell you we are having two values for x. Are we getting that? So it doesn't matter. So you write it this way. Are we okay? So since the denominators are the same as what the coefficients, what do? We change their signs. So changing this one will get me -3, or This one too is equal to positive what? 1. Are you with me? So this one is what? Negative 3, and this one is positive 1. Right after you are done, the two numbers after changing is what? The two numbers we are looking for. So we multiply this one by 1, this one we get negative 3. So negative 3 times 1 is negative 3. And when we add negative 3 to what? 1, we get what? Or when we add 1 to negative 3, we get what? Negative 2. And it's the same. So wherever we see negative 2, we put this. Are we getting that? And this one will be what? X squared minus, yes, 3x. So negative 3, that's what is it? Plus what? 1. And that is plus x. We don't have 1x. Then the constant is what? Negative 3, which is equal to 0. Then we group. We factorize. Please, are we getting that? Okay, let's take another one. A situation whereby the coefficient is not 1. And we see what I was talking about. Okay. Okay. So that one says 2x squared minus x. 2x squared minus x minus, is it 3, which is equal to 0? Yeah, minus 3 is equal to 0. So the same thing, we put it on the calculator. So equal to, then it comes back to normal. So we put it. So I have 2 for this one, and this one is negative 1. Negative 1. Don't put just negative and go. Yes, 1, but we don't write. Because negative, if you just put here negative, it will give you 1 0. So it's negative 1. And this is what? Negative 3. So after putting that one, you see we are having x to be equal to 3 on 2. And the next one is what? X is equal to negative 1. So now, I said, since now here is what? 2. The denominators of the answers are supposed to be 2, 2. That is why here we are having the denominator here to be 2. And here the denominator here is supposed, the answer is negative 1, right? Sorry, it's negative 1. So we are supposed to have the denominator to be what? 2. And here is what? Over 1. So we can write the equivalent fraction or a fraction that is equivalent to this one, a situation whereby the denominator is what? 2. So we can form one right now, like what we were doing in the previous videos. Are we okay? So what do we do? I take this one. So I have negative 1. Are we getting that? So let me even do it here. Negative 1 is over 1. It's over 1, but we don't write. Negative 1 is over 1, but we don't write. So what do? I can multiply here by 2, so that the denominator will be 2. Then what we do to the down, we do the same to the top. Are we getting that? And this one is now getting us, let me write it here. It's now getting us what? Negative 2 on 2. So now we have what? The x's to be what? 3 on 2 and what? Negative 2 on what? 2. And we know that negative 2 on 2 is the same as negative 1. Are we getting that? We've not done anything. Just that we wrote what? Equivalent fraction of what? This one. Are we getting that? When we say equivalent fractions, there are 2 or more fractions having the same words, answer, or the same value but of different form. Their values are the same, but their forms are different. The form for this one is different from this one. But the value, the answer, they are the same. Please, are we getting that? When I put this on the calculator, I still get negative 1. Are we okay? We wanted to have denominator. So when you are solving, you are going to get this one before you solve to get this one. Are we getting that? So I said, if the denominator, if the coefficient is other than 1, or it's a number other than 1, or it's a number that is not what? 1, always the denominator will also not be what? 1 for the answers. So all that I mean is what? The denominator of the answers should be the same as that of what? The coefficient of the x squared. And now we've made them what? The same. And since the denominators are what? The same as the coefficient of the x squared, now we change their sign. So changing the sign of this one will have negative 3 on what? 2. And that of this one will be what? 2 on 2. Are we getting that? All that we did, this one we didn't do anything to it because the denominator is the same as this one. But here it was over 1. So we wrote it to be having what? The denominator was 2. So that is equivalent fraction. This one will be doing it. Okay, so we have that. And we interchanged or we changed their signs. So changing their signs, we have this. And we said after changing their signs, what do? Now we take the top numbers. You see, when we were having x to be equal to, let's say, 3 and x to be equal to -1, all that we were doing was taking the top. We were not interested in the down. Are we getting that? So the same thing applies to this one. But we wanted to have the denominators to be the same before we choose the tops. Because this one, if we had taken 3, -3, and this one would have been 1. Are we getting that? 1, it will be -3 times 1, which is what? -4, 3. But this one will multiply this to get -6. Are we getting that? So it will not be the same. That is why I have to make the denominators the same. So now our two numbers are what? This and that. What is what? -3 and +2. So what do? We multiply this one by this to have -6. So two numbers multiplying to get -6. That's this and that. -3 times 2, we get that -6. And when we add 2 to what? -3, we get what? -1. Is it not easy? Okay. Isn't it easy? And it is very easy. So let's proceed. Then what do? After having the -3 and the next thing, we substitute it here. Are we getting that? That is that. We substitute it here. Then we proceed. Let's take last example. Or last but one example. I also have 3x squared minus 8x. Is it minus 8? Minus 8x plus what? 5 is equal to 0. So what do? We quickly put it on the calculator. So the calculator is getting us here to be 3, here to be -8. This one to be the constant is now +5. So I put my +5. And I'm having x to be equal to what? 5 on 3. Or x to be equal to, then I put, that is 1. Are we getting that? So now, what do? The first thing I have to make sure is that the denominators are the same. Here is 3 as this one, but here is not 3. This one is over 1. So what do? I can form this one. So we have 1 over 1 times, that is what? Let me write it here. Times, and this one 2 times. 1 times what number will get me? 3. That is 3. And here to 3. So this one will get me 3 over 3, and this one will get me. Now I'm having what? The denominators to be what? The same. So I now have 5 on 3, and what? This one too is what? 3 on 3. So the denominators are now the same as this one. Then I do what? I change their signs to be -5 on 3. And this one too is what? -3 on 3. Because positive, so it will be negative. Then I take their tops. So therefore the numbers are -5 and -3. So multiply this by that, we'll get that what? 15. So negative times negative is positive. Then 5 times 3 is what? 15. Are we getting that? And when we add this to this or this to that, we get the -8. Are we getting that? And they are the two numbers. So wherever we see what is, we put this. Are we okay? Last one. Last one. Last one. Last one. Last one. That one is 6x squared. 6x squared. Is it plus or minus? Minus 23x. Then plus or minus 55. Oh. So when we multiply this by this, somebody is saying, say, I want to multiply this by that. By the calculator, even if I click on AC or the on, yes, so I'm having the A, B, C there. That is what the quadratic equation there. Just click on the mode and you click on number 1 and it will go back to normal. Click on mode, you click on 1, it will go back to normal. Then I want you to put this. That is 6 times 5. 6 times -55. 6 times -55. And that one is getting me negative 330. So I'm going to find two numbers. When I multiply, I get this. But when I add, I get negative 23. Is it easy? No. By using my method or the method I was speaking about, it's very simple to get those two numbers. You cannot just replace them with any numbers. It will make you, or it will make your answer wrong unless you get the correct numbers. So what do? We put this on the calculator. So like what you were saying, you go to mode number 5, number 3. Then this one is 6. This one is negative 23. This one is negative 55. Clicking on the equal sign will get you now x is equal to 11 on 2, and another x is equal to negative 5 on 3. Are we getting that? Okay, so now what do we do? Here the coefficient here is 6, so the denominators are supposed to be 6, right? But here is 2, here is 3, none of them is 6. So we can form them. So I'm going to have 11 on 2, then times. Are we getting that? 2 times what number will get me the 6? That is 3. I give the same top. So this one will now get me what? 33 on 6. This one is equivalent to this. Because if you put this on the calculator, you get to find that. Okay. Then this one too is giving me negative 5 on 3. This one times. So 3 times what number will get me 6? That is 2. And this one too is 2. So this one will get me negative 15. Sorry. Hey! Negative 10 on what? 6. And 6. Negative 10 on 6. Let me come again. Negative 10 on 6. So when you put this on the calculator, it will get you back that. Are we okay? So now the denominators are the same. So what do I do next? I hope you said you change your signs. So changing your signs will get me negative 33 over 6. Then this one too is what? 10 over 6. Are we getting that? Now we take the top numbers. So here I have negative 33 and that is 10. So when I multiply this by this, I get what? Negative 333. And when I add them, I get negative 23. So wherever I see this, I put this and that. Are we okay? Voila! So that is what we are going to be using, or we are going to be seeing the some of the remaining examples. Please, are we getting that? Okay. Let's now proceed with this one. So this one, we want to extend this one to the 410. So we have to get our two numbers, right? So we know first thing we have to put this on the calculator. And what we are going to do, all that I was showing here, we are not bringing them on board you. You do it somewhere, then you bring the two numbers. We are doing that to get only the two numbers, then we bring them here. Are we getting that? So we put this on the calculator. Putting it on the calculator. I'm waiting for you. What are you getting? Were you able to get the two numbers? Get the two numbers for me. If you don't get the two numbers, I won't solve. So you can pause and get the two numbers. Are you doing as I'm saying? Okay. Some are still not pausing. They are waiting for me to do it. Pause. I can see you. Pause. Okay. So now putting it, I have 1. Putting the equal sign, I have what? Positive 2 equal to, then I have negative what? 35. So putting equal sign, I have what? X to be equal to 5, and x to be equal to negative 7. So the denominator is 1, and the coefficient here is 1. So they are the same. So what do? I interchange, or I change their sign. So this one will be negative 5, and this one will be 7. So the two numbers are negative 5 and what? 7. So when I multiply this by 1, 1 by this, I get negative 35. So this times this is negative 35. When I add the 2, I get a positive 2. So that is it. Voila. So wherever we see what? This one, we substitute with what this. So we put, this implies that x squared. Then this one is minus 5 what? X, then plus 7x, Are we here? Then minus what is less? Because we said only this, we are putting this, but we have this one is equal to 0. Then this one will get us. What do we do next? We group them into 2. Then what are we doing now? Let's proceed. Let's proceed. So we take what? The sign that comes first, that is positive. So here is positive. Then what are we going to do? We are going to factorize signs, coefficients, then what? The variables. So the sign, I have positive and negative here. Positive for this term, negative for this term. But we take the sign that comes first, so that's positive. Are you getting that? And here is 1, here is 5. So 1 is common. So I've taken 1, 2. Are you getting that? So positive 1, I'm having positive 1 for now. Then I have x squared and what? X. So that one too, we take the one with the least what? Exponent. Are you getting that? So x squared x. So I factorize what? X. So I have positive 1x. Are we getting that? Right after you are done factorizing them out, then what are we doing? You take them into what? The term. So I have positive divided by positive is positive. I have 1 here divided by 1 is what? 1. Then I have x squared divided by x. That is x squared divided by x. Please, are we getting that? And we use the law of indices. Since the bases are the same and we are dividing, we subtract the exponent. So this one gets me x squared minus 1, which is what? X exponent 1 is the same as what? X. So we see what? X squared divided by x is what? X. So we are having positive 1x. Are we getting that? Okay. So let me write it all. So now I have, x out. Then I have x, I'm done. Then what do I do? I have negative divided by the positive here, and that one too is what? Negative. Then I have 5 divided by the 1 here, which is what? 5. Then x, there is nothing here. X divided by x will be what? 0. That is x over what? X. And the bases are the same, they are they are dividing, so we subtract. So I'll have x exponent 1 minus 1. Are we getting that? We are subtracting the exponent. So I'll have x exponent 0. That is what? 1. Any number exponent 0 is what? 1. So meaning x divided by x is what? 1. So it will multiply the 5 to get the 5. That is why we say this one will answer that. And what is left? 1 over 1. And it's what? 1. Are we getting that? Okay. Then I do the same thing here. So this one to the sign is positive. I would have written minus if minus is beginning. So don't say I have positive and I have minus, I'm taking 1. No. We take the sign that comes first. Okay. Then I have 7, 35. 7 is common. So I bring 7 because 7 can go into 7. 7 can go into 35. Are we getting that? Then x is here. There's no x here. So x is not common. Are we getting that? We are done. So positive divided by positive is positive. 7 divided by 7 is 1. Then x divided by 1 is what? X. Are we getting that? So I have 1, positive 1, x. Then negative divided by positive is negative. 35 divided by 7 is what? 5. Then equals to 7. Are we okay? Then what do I do next? What do I do? So now we proceed. And in proceeding, we have, since what is inside the parentheses are the same, we form what is outside. I said, since what is inside the parentheses are the same, we form what is outside to be in one bracket. Are we getting that? Okay, or we form a bracket for what is outside. So what is outside? I have x, then plus 7, plus 7. Then I take one of the parentheses. So that is x minus 5. Because they are the same, which is equal to 7. So if here is positive and here is negative, which one are you taking? Is it the plus or the minus? That is why they have to be the same. So whenever you do it and they are not the same, meaning there is something wrong with your calculations. Please, are we getting that? Okay, so you have to make sure they are the same. So why if they are not the same, you can't form those outside to be in one bracket. That is why I said what? If what is inside the parentheses are the same, you form what is inside to be in one bracket. That is the law we use for what? Factorization of quadratic trinomial. Are we getting that in algebraic expressions? Okay, so this one will now get as what? And there's something I have to speak about here. So, in mathematics, whenever you're having AB is equal to what? 0. Meaning A times B is equal to 0. So meaning what? For us to get to a 0, then one of what? These values has to be what? 0. All can never be 0. Are we getting that? As a situation whereby we say what? We will say what? A and B are 0. No. If A and B are 0, then what are we solving? Are we getting that? So for us to get the answer to be 0, then it's either this that is 0 or this that is 0. Meaning one of these is 0. That is why the answer is what? 0. Because 0 by anything is what? 0. Please, are we getting that? So having this one, for us to get 0, is either the A that is 0 that is multiplying the B to get 0, or is the B that is 0 to multiplying the A to get what? 0. Are we getting that? So how do we write this mathematically? This is how it is written. We have A, which is 0, or is either what? B, that is what? 0. So it's either A that is 0 or B that is what? 0. Please, are we getting that? Another way, if I have 2x multiplying x minus 1, what do we do? And it's equal to 0. So product, this one multiplying this one. Are we getting that? So it's either the 2x that is 0 multiplying the x minus 1 to get 0, or it's the x minus 1 that is 0 multiplying what? The 2x to get what? 0. Please, are we getting that? So this one too can be written as 2x is either 2x that is 0 or x minus 1 that is what? 0. Then this one leads to what? Linear equation. We solve it and get the value for what? X. That can make it what? 0. Are we getting that? Are we okay? Are we okay? Okay. So let's see. So having this one to the same idea, product, this one multiplying this, and the answer is 0. So it's either this that is 0 multiplying this one to get 0, or this that is 0 multiplying this one to get 0. Are we getting that? So this one will get us what? X plus 7. It's either this one that is 0, or x minus 5 that is what? 0. So solving this will get me x is equal to positive, negative what? 7. Or x is equal to positive 5. Are we okay? So it's either what? X is equal to x that is equal to negative 7, or x being equal to what? 5. So when we put here x to be equal to what? Negative 7. So negative 7 plus 7. Here we go to 0. 0 by this we get that 0. Are we getting that? Or when we get what? X to be 5. 5 minus 5 will go to 0. And 0 will multiply this and it will be 0. That is why we said it's either this that is 0 multiplying this to get that 0. That is how to write this. Please, are we getting that? Okay. So these are what? The possible values for x that will make what? This one go to what? 0. Are we getting that? Are we getting that? Okay. So these are what? The values for what? X. And since we are referring to quadratic equations, we get two answers, and that is that. And we are on the number basis, we are finding what? The base number, x. So then we know the base number 2 can never be what? Negative. So therefore we say what? Therefore x is equal to what? Positive 5. Since whatever. Since what? A base number can never be what? Negative. Are we getting that? So all that we mean is that what value of x when we put here will make what? The statement true. That is 1, 2, 3 base 5. Because we are saying x is 5. When we convert to base 10 and we convert it back to what? Or we convert that base 10 back to base 6, we get what is. Are we getting that? So you put 5 here, you convert it to what? Base 10, because we said to convert from other base to other base. What do? We first of all convert to base what? 10. We first of all convert it to what? Base 10. Then we convert our results back to what? Base. Or the required base. Are we getting that? Okay. So I'm having this being equal to that. So you can verify that or you can prove that. And we get to see they are going to be what? The same. Are we okay? Okay. So that is that. So therefore x. So immediately you get to this side, that is not the values for x. And if all had been positive, that is when we say what? It's either this or that. Because we said what? The base number is always what? Positive. But this one we're having negative and positive. So the answer should be the what? Positive number. Are we okay? Okay. So let's now proceed. So that is that for what? Example number 4. We now move on to example number